Welcome to the most relevant series on modulus functions with respect to IIT JEE. In this first two parts of this series, we discussed about the modulus basic definition and properties. In the second part, we discussed about graphical transformation. So, if you are aware with those ideas, today we are going to move towards modulus equation. But if you aren't aware with those ideas, it is highly recommendable that you go back and watch those two first and then come on to this one. So, without any further delay, let us start with it. So, let us look into the mind map. We have already done the definition, we have done properties, we have done graphical transformation, and now this will culminate into problem solving in equation. So, the first thing that we need to know about any kind of modulus equation is this basic idea, that is how to use our interpretation technique that we learnt in the first part to solve questions. So, we have been given a question like this, but before I take this question, I will do an even basic question that will help you understand this very fast in 2-3 steps. Is if we have been given modulus of x is equal to 2, this is the first case. If you do this, the actual method is, I will have to take two cases. The first case is if I consider x is greater than or equal to 0, then in that situation this will become x, then x is equal to 2. You can see that since 2 is greater than 0, this is fine, this is an acceptable answer. Another thing I will have to consider is one more case when x is smaller than 0. In this case, modulus would be interpreted with a minus sign, and now corresponding to this the value of x comes out to be minus 2, and this is also fine because this is a value smaller than 0, which was the original condition. Considering both of these, we can write the final answer as x equal to plus minus 2. So, now what I am saying is, whenever x is a positive value, this is always going to happen, and hence if you get a modulus sign equal to something, you can directly write it as x is equal to plus minus a. This will become a shortcut or a hack that we are going to use. The next case is, it could as well happen that the modulus that is given in equation comes out to be equal to minus 2. Now, in this specific situation, modulus can never be negative. So, in this case, you will have no solution or x belongs to null set. So, using these two cases, you can simplify your interpretation technique. So, let me show you how to do that. So, if I want to solve this question, there are two ways to do it. In the first way, we are going to use interpretation. That is the core technique. So, I am going to take whatever is inside the modulus first as greater than 0, equal to 0. So, what I get from here in my case 1 is x is greater than or equal to 5 by 2. Now, since we are looking into values that are greater than or equal to 0, the modulus will open with a positive sign, and then this would be equated to x minus 1, x will get cancelled out. The value of x, if I solve this, comes out to be 4. Now, since 4 is greater than 2.5 or 5 by 2, this is an acceptable answer, there is no problem with this. In the next case that I have, I will consider those values of x when it is smaller than 5 by 2. So, this modulus sign now will open with a negative sign, minus 2x minus 5 is equal to x minus 1, and if you do this now, it becomes minus 2x plus 5 is equal to x minus 1. So, minus 3x would be equal to minus 6, or x will be equal to 2. Since 2 is smaller than 5 by 2, it is an acceptable answer. So, this is the actual technique, in modulus to solve questions. But now, in this second part, I am going to innovate over this technique and develop a simpler technique. So, what I have told you earlier, assuming that this portion that is written on this side, I am assuming, I am not even checking. Okay. What I will do is basically, or you can make two cases, x is greater than 1, you can also write that. But I am even not doing that, I am making it very short. So, this is a shortcut, this is not a technique per se. You should remember this, because in shortcuts, you will have to put checks and balances. Now, once you have got this, what we did here, we are going to put a plus minus sign when we remove the modulus. So, I am going to write this and put a plus sign and a minus sign. Now, in order to get the plus wala answer, I will first solve it for plus sign and then ultimately solve it for the minus sign. So, it becomes 2x minus 5 is equal to x minus 1, x comes out to be equal to 4. And then again I am going to take the minus sign. So, 2x minus 5 is equal to minus x plus 1. 3x is equal to 6, or x comes out to be equal to 2. Now this is not where the question ends. There is going to be and there should be a next step that I am going to call as check. So you need to check your answers. So what you are going to do is take the first answer, that is x equal to 4, and put it in the original equation. See, I am not going to put it here, I am going to put it in the original question, that is 2x minus 5 mod. Now this should come out equal to x minus 1. If I put 4 here, it is becoming 8 minus 5, that is 3. And if I put 4 here, it again comes out to be 3. These are equal. So this is fine, you can accept this value. Similarly, I am going to do it for 2 as well. I am going to put it on the left hand side, 2x minus 5 mod is equal to x minus 1, and see what are the values am I getting. If I put 2, this becomes 4 minus 1, then mod becomes 1. And here if I put, again I get 1. So you can see that again you are getting it equal, so this is also an acceptable value. So we have got two answers for this question, 2 and 4. Let me write it, let me go back one more time. So see, there are two techniques. One, we can do actual interpretation, and this is the most authentic way of doing things, but sometimes it will become lengthy. So we have got a shortcut where we remove the modulus sign and put a plus minus. Now this technique will only work. Okay, so there is a, whenever you have a technique, you have a validity to that technique, that when there is only one mod, then only you can do this, otherwise this technique won't work. Okay, so this is very important thing that we need to consider by solving such kind of questions. Let us take one more question on the similar type. So you have this. Now I am not going to show you the interpretation method, because in more complex questions we are going to use this method. I am going to use the simpler method. So in the first step, I am going to write it down, remove the modulus sign and put a plus and minus sign in front of, actually I am putting plus and minus here, but I am writing it on the other side because it will make calculation simpler. Now if I take the plus sign, let us see what do I get. It becomes x square minus x minus 6 is equal to x plus 2. That eventually becomes x square minus 2x minus 8 equal to 0, and this can be written as x minus 4 into x plus 2 equal to 0. So two values of x, plus 4 and minus 2. Again we are going to do it for the minus sign. So in this case, x square minus x minus 6 would be equal to minus x minus 2. So what we are getting is x square minus 4 is equal to 0. This will become x minus 2 into x plus 2, and hence the value of x comes out to be plus minus 2. Now you can see that in the first step we have got three different answers. So solutions are 3, roots are 4. What are those answers? We have got minus 2, then there is plus 2, then there is plus 4. So we'll have to check for each of these. So now let us write the question and see what happens in each of these cases. Wherein here if I put this, again comes out to be 0, and now this is fine. So this is an acceptable answer. We will do this one more time for the B part. So let us now consider the value of x is 2. What we have is x square minus x minus 6 mod is equal to x plus 2. If I put 2 here, becomes 4 minus 2 minus 6 mod, and that would be equal to 4. If I put 2 here, it becomes 4. Again this is equal, so acceptable. In the C part, I am going to do the same thing for plus 4. Now where am I doing it? In the next few questions I might not do it, but you should always do it. So this is a rule, whenever you are using a shortcut you will have to do it. If you use the interpretation technique, you don't require it. So here we will put 4, becomes 16 minus 4 minus 6 mod. You can see that this comes out to be 6. Here also if you put the value, comes out to be 6. Both of these are equal and hence acceptable values. So in this question we can see that all the three solutions, minus 2, plus 2 and plus 4, are acceptable solutions. And there are two techniques, only valid there is one modulus sign. Remember this is a very important idea. Now once you do this, let us go to more complex question. Like in this question, it would be difficult to apply this idea. So now if I look into this next question, you will see that there are two modulus signs. So applying this idea that we did earlier might become slightly difficult. So we should go into more primitive idea, that is interpretation of modulus. Now in the case 1, what we are going to do is first remove this modulus sign. So let us rewrite the question before doing anything. I can write this as x minus mod of x minus 4, because mod of x is equal to mod of minus x minus 2x minus 4 equal to 0. I have brought everything on the left hand side. Once I have written it like this, largely we are going to first try and remove this modulus sign. So in this first case, I am taking this as greater than equal to 0. So what is happening here? As a result, x would be greater than equal to 4. This is the first value. If I do this, what happens on the left hand side? The first modulus sign, that is inside, open with a positive sign. The minus was already there, I have not done anything with that. If you simplify this, this comes out to be 4. This is 2x minus 4 is equal to 0. Again it cancels out, the value of x comes out to be 0. Now x is coming out to be 0, we are talking about values of x greater than 4. So you can see that this is not greater than 4, hence not applicable. Let us take a case 2 now. In this case 2, we are considering the value of x minus 4 as smaller than 0. If I do this, what is going to happen? This modulus will open with a negative sign. Hence this minus inside the mod will go away. Okay. Now if I solve this, this becomes 2x minus 4 modulus is equal to minus 2x minus 4. Now there would be simpler techniques to solve this, but let us do using the crudest of technique that we did earlier. So now again, since there is one mod available, I can use my shortcut. I can open this with a plus minus sign. If you want to do it, you can take this part on the other hand side and write this as 2x plus 4 and then open with a plus minus sign. So you can write this as 2x minus 4 is equal to plus minus 2x plus 4. Now what we can do is we can again consider the plus sign and the minus sign and then check the answers. So if I take the plus sign, it becomes 2x minus 4 is equal to 2x plus 4. This cancels out, minus 4 is equal to 4. This is impossible. Had it been plus 4, then we will have to do something else, and I will see what we will do in that case. But if I take the minus sign, it becomes minus 2x minus 4. So again what you are getting is here 4x is equal to 0 or x is equal to 0. Now see, what we will have to do is we will have to put it in the original condition that we have got. The original condition in this case is this condition. So in this condition we will have to put and check. So in the next part, what am I doing? I am checking it. So if I check the answers that I have got, I am going to take x equal to 0, put it in this condition and see what happens. So this becomes minus 4 on the left hand side and 4 on the right hand side. See, both of them are equal, hence it satisfies. So this is very important to understand. We always need to check. Now one more thing, it is satisfying this condition, but is it satisfying this condition? Is it smaller than 4? Yes, it is also smaller than 4. It takes out the second condition also, as this is an acceptable solution. So we got the same answer in both the cases, case 1 and case 2, but in one it was not an acceptable answer because we are looking for values greater than 4. This is important beta. And here it is an acceptable answer because we are looking for values smaller than 4. Now once we have covered the basic things, now let us go into more tricky property based questions, because these are the questions that are usually asked in the exam. Now once you have this, somebody is giving you mod of fx is equal to fx. See, this can only happen when the function inside the mod is greater than equal to 0. So what will happen is when this equation is given, we can directly write that this is only possible if this happens, and hence this, from here whatever we will get will become the solution of the question. Very important. Now let us look into a question based on this. You can see that there is a function here. So we will have to read between the lines, and it says it is equal to the same function. Then what are you going to do? We are going to say that whatever is function, this is only possible it is greater than equal to 0. The answer of this question becomes x is greater than equal to 2. That means that if you take any value of x greater than 2 and satisfy in this equation, this is going to satisfy, and hence the answer comes out to be 2 to infinity. Any value between 2 and infinity is going to satisfy this equation. Let us do this one more time with a slightly more complex question. You can see here, and we can write as complex question as possible. Here it will ultimately become a question of inequality. So again, there is a modulus given, same function is written in front of that. If you can notice this thing, instead of doing interpretation, see, interpretation technique is a mother technique. It can solve any question in any form. In fact, our shortcut might also get applied. But if you can just observe this, your question becomes that much easier to solve. So if you have this, you can directly write x square minus 3x plus 2 is greater than or equal to 0, because whatever is function inside, that needs to be greater than or equal to 0. This we will be able to write as x minus 1 into x minus 2. And now this can be solved using VV curve method or method of intervals. We will plot 1 and 2 on the number line and draw a wave that goes like this. So positive, negative, positive becomes 0 at 1 and 2. You can see that the answer becomes minus infinity to 1 union 2 to infinity. Any value in this duration is going to satisfy the equation. So very simple, very efficient way of doing things. In this type 3 questions, you can see that same kind of thing is given, but instead of a plus sign, there is a minus sign here. You can again see that this will only happen when function becomes smaller than or equal to 0. See, equal to 0 would still be valid. Okay, so this we are going to interpret like this and solve the question very fast. So again, this becomes a shortcut. Not to discount the original method, interpretation can be used, shortcut can still be used. But when you see like this in a question, you have got again one more shortcut ka shortcut. And that is very important to understand. So now here you can write this fx as smaller than or equal to 0. So what will happen here? X minus 2 would be smaller than or equal to 0. X becomes smaller than or equal to t, which would mean any value of x smaller than 2 that would lie between minus infinity and 2, including 2, will satisfy this equation. Let us do it one more time or a slightly more complex inequality that is going to form. Same kind of pattern getting observed here. Mod of fx is equal to minus of fx. So what are we going to do? Fx, that is x square minus 3x plus 2, should be smaller than or equal to 0. This can be written as x minus 1, x minus 2 after factorization. We can apply VV curve. We have got 1 and 2 on the number line. We will draw a wave, plus minus plus. We will include this point because there is an equal to sign. Answer becomes any value between 1 and 2 closed. This becomes the answer to this question. Now, type 4 questions are based on addition subtraction property. Now, these are the most important kind of questions that are asked on modulus equation. And this is based on the same u-v property that we saw earlier. Let me give you a quick revision of what we did there. So, what we looked into are two specific cases. See, if you have u and plus v ka mod, it will become u ka mod plus v ka mod only when both of them have the same sign. That would mean u into v is greater than or equal to 0. Sometimes u plus v ka mod, this would be smaller than u ka mod plus v ka mod. This will only happen if u and v have opposite sign. So, u into v is smaller than 0. And in general, you can always write, and general we are not going to use any time when you are solving question is u plus v ka mod is smaller than or equal to u ka mod plus v ka mod. So, this we are never going to use. These first two things are the things that we are going to use while solving questions. Okay. So, now let us look into this question. What you have to do is you have to correctly identify u and v. So, what is happening here? This is my u. So, this will becomes x minus 1 ka mod. This is my v, 2 minus x square. And what is happening here? If you see that 1 is written, but actually what is happening is it is written x square minus 1 and 2x. So, you can see that if you add these two, ultimately you will get 1. This is important thing to notice. So, what is happening here? U ka mod plus v ka mod is equal to u plus v ka mod. So, this happens only when u into v is greater than or equal to 0. So, in order to find the solution of this question, once you have observed this in the first step, in the next step, you will have to multiply the functions inside the modulus and put them greater than or equal to 0. Now, we can factorize this. In the first step, we are going to take a minus sign common from the second part. If I take this minus sign on the other side, you will see that the sign of the inequality will flip. This can be written as x minus 1, x plus 1. The second part can be written as x minus root 2. X plus root 2 is smaller than or equal to 0. And now if I solve this using VV curve method, I will have to draw a number line. Put all of these numbers. Minus root 2 is there. Minus 1 plus root 2. We will start from here. We are going to draw a curve that alternates between the signs. Plus, minus, plus, minus, plus. You can see that there is an equal to sign here. We will include the points where it becomes 0. If there had not been equal to, we will exclude those points. We want values smaller than or equal to 0, so my answer becomes minus root 2 to minus 1. Here it is negative, we will include the points. Union 1 to root 2. Okay, so these are the values that are going to satisfy this equation. This is a very efficient way of doing things. If you do it solving inequalities, interpretations, then it is going to become an extremely long question, and then you might not be able to get question right, because the questions that have longer solutions will also have problems of accuracy when you try and implement it. Now let us look into the next one. Again, you can pause the video and try doing it, but in case you can directly observe, you will see that this is my u, this is my v. So what is written is mod of u plus v on the right hand side, and then this is modulus of u, modulus of v. Reminds me of this property, u plus v ka mod is smaller than u ka mod plus v ka mod, and this happens only when u into v is smaller than 0. Okay. So in the next part, what we are going to do is, we are going to write u, x square plus 2x plus 2. We are going to multiply it v, that is 3x plus 7, and put it as smaller than 0. Now after this, we will have to view our magic. Now this part, if you very closely observe, a is greater than 0, and if you find the value of d, it would be b square minus 4ac becomes smaller than 0. That would mean this will be a polynomial function whose graph would be above x-axis, and hence this will always be positive. This is important, and this is very important. When I taught you quadratic equation, we talked about this idea that this is used quite some time. So this is not going to have any impact. So in the third step, we can just write 3x plus 7 should be smaller than 0, and as a result x would be smaller than minus 7 by 3. This becomes my answer. So answer of this question is minus infinity to minus 7 by 3. Open on both the sides. This is the solution to this question. Moving on to the next question. Again, I think now we should be able to handle it. I am not going to solve it till the last step. I am going to just write the first few steps. You can see that this is x square minus 9 ka mod plus x square minus 4 ka mod. So right hand side, you can write it like this, x square minus 9. But if I write here plus x square minus 4, it does not adds up. Ghapla will happen. So to adjust this out, we need to do a slight manipulation. So what you are going to do, this is not working out, but if I rewrite it like this, instead of doing it like this, if I rewrite it like this, I write it as 9 minus x square. This I write it as x square minus 4. Now it works out, because now if I add both of these, then it will become 5. It becomes 5. So you can see that this slight manipulation and writing it like this has resulted in me having the ability to apply the property. So now I can apply the property. This can only happen when, so what is happening is u ka mod plus v ka mod is equal to u plus v ka mod. So this will only happen when u into v is greater than or equal to 0. So what happens is 9 minus x square into x square minus 4 would be greater than or equal to 0. If I take a minus sign common, that minus sign will go on the other side, will flip the middle sign. We will be able to write this as x minus 3, x plus 3, x minus 2, x plus 2 is smaller than or equal to 0. In the third part, we are going to draw the wavy curve. To draw the number line, put the points minus 3, minus 2, plus 2, plus 3, and draw an alternating graph between both of these. plus minus plus minus plus. Since we want values of x smaller than equal to, there is an equal to sign. We are going to include the middle points. So answer becomes minus 3 to minus 2 close. Union plus 2 to plus 3 closed. Let us do slightly more complex question now. Here you can again see that what you have got is a minus sign here. Okay. So there could be a property for minus sign also that we can do. In fact, we did it earlier. But if you don't want to do it, you can still use the property that I have taught you. All you need to do is in x square minus 9 minus x square plus 3. This is given. We can take this x square minus plus 3 on the left hand side. And this gets converted into the old property that we did. Okay. So sometimes you can manipulate the question. So instead of writing lot of things and remembering lot of things, it is always better to remember few things and apply it nicely. So now you can clearly see that there is a u here. There is a v here, that if you add, you will get the left hand side. So this will only happen when u into v is greater than or equal to 0. So we can write x raised to the power 4 minus 9 minus x square minus 3. This is my u, and then v, that is nothing but x square plus 3. This should be greater than or equal to 0. If I simplify the first part, after that it is calculation, becomes x raised to the power 4 minus x square minus 12, and the second part is x square plus 3. Now we can again see that, see this part, the second part is very peculiar, because in this quadratic a is greater than 0 and d is smaller than 0, what we looked into the earlier question. So this is always going to be positive. Why? Because if you draw the curve, it is above x-axis and hence it is always positive. Okay. So if I do this much, the answer of this question will just come by solving the first part of this inequality, that is x raised to the power 4 minus x square minus 12 is greater than or equal to 0. Now देखो, if you want to solve this, it is not such a difficult thing, because we can factorize this as x square minus 4 and x square plus 3. Now once you write it down, again this is not going to make any sense, same thing what happened with the earlier part. So whatever we will get would be from this first part, that is x square minus 4. So it looked like a difficult question to solve. There is a 4th degree inequation getting formed, and then ultimately it became a simple question. X square minus 4 should be greater than or equal to 0. This we can write as x minus 2, x plus 2. Again you can draw the wavy curve and directly write the answer as minus infinity to minus 2 union 2 to infinity. Okay. What I have done, I have drawn the wavy curve. Denoted this point as minus 2, this is plus 2, and again a curve that goes like this. We will consider these points as well. So this is the answer to this question. Now let us look into a question that is even more interesting and does not looks or appears to be a question based on modulus right from the face value itself. Like this question is given to us. They are asking us to prove this question. It could be a multiple choice question as well. So now first let us understand and interpret what the question says. So before that, let us again further break it down, understand one part of the question. So what is given is x, then 2 root x minus 1. Okay. So this is the important part, how you understand one fraction or one part. So whenever a tough question is given to you, don't focus on the whole question right from the starting. Focus on individual parts of the question. See whether you can get some pattern out of it. Okay. So I will show the first one. From that you will also understand what to do in the next one. If I take this question, what is happening now? See, this can be written as x minus 1 plus 1 plus 2 root x minus 1. And if I do one more step, you will be able to understand what am I doing. So if I write this as root of x minus 1 whole square, it will still be x minus 1. This will become 1 square. This is 2 into root x minus 1, then into 1. So you can see that I have generated a formula a square plus b square plus 2ab inside this root. So this can eventually be written as nothing but a root of x minus 1 plus 1 whole square. And whenever there is a root of a square thing, it is interpreted as modulus. So what I have got is this modulus. This is a very important thing that I have done, and sometimes question might not directly say, but this is what they want you to do. If you have understood this, the next part will become simpler for you, because it is exactly the same statement with a minus sign in between. So you can pause the video and try doing it on your own, or you can watch the video. So what I am doing is this, I have written like this. I will put plus 1, 2 root x minus 1, and then again in the next part we can write this as root of x minus 1 whole square plus 1 square. Instead of plus there is a minus sign, 2 root x minus 1 into 1, and this will become root of x minus 1 minus 1 ka whole square. That becomes root of x minus 1 minus 1. Once you have got this, in the third step, we have got the modulus inequality equation or expression that we are waiting for. So the first part became equal to mod of root of x minus 1 plus 1 modulus, and then the second part became root of x minus 1 minus 1 modulus. You can see that there are two parts now, and now we can use the idea that we were earlier talking about. Now this can have two different values. One is the minimum value, another is going to be the maximum value. So now here you can understand it in a very simple manner. Once you have done it till here, we can interpret it two ways. So what we can say is, this is my u. So what we have been given is mod of u plus mod of v. What I am saying that this can be written as u plus v ka mod. When we will be able to write this? When u into v is greater than or equal to 0. So using this, what I can do is I can write this as modulus of, if I add both the things inside the mod. So this is the first thing, this is the next thing. You can see that this becomes 2 root x minus 1. Modulus over a root makes no sense because it is already a positive quantity. So this will happen when you have root of x minus 1 plus 1 into root of x minus 1 minus 1. This multiplies and is greater than or equal to 0. So becomes x minus 1 minus 1 is greater than or equal to 0, or x minus 2 is greater than or equal to 0, or x is greater than or equal to 2. So this first result comes when x is greater than or equal to 2. Now let us move towards the next result. Let us see that what happens in that case. So in the second part, what are we saying now? So instead of doing or writing the question in this manner, I can take the first one, I can write it the same, but the second one I can flip and write it as 1 minus root of x minus 1. If I write it like this, still the logic would be same, and applying the logic, if I add them up now x minus 1 plus 1 will happen, then 1 minus root of x minus 1 would happen, and this will get now cancelled out, and answer becomes 2. Now when will this happen? So this will happen only if u into v, that is root of x minus 1 minus 1 plus and 1 minus root of x minus 1, this is greater than or equal to 0. We are using the same idea, we are just flipping the sign here in between. If you write it like this, then what is going to be the answer? Now this will become 1 minus x minus 1 is greater than or equal to 0, and this becomes nothing but, this is 1, this is minus, this is plus 1. So this becomes nothing but x is smaller than or equal to 2. You can see that when this is true, the answer becomes 2. This is what the question says. Now let us go back to the question. Question says that when you take values between greater than 2, this is how it looks like. If you take values when smaller than 2, it becomes 2. This is what it says. So it is exactly saying the same thing what we did. Now you might wonder that why are they putting greater than 1? Because see, this is written inside the modulus sign, the root sign. So it is only possible when the value of x are greater than or equal to 0. Hence, we can only consider values of x greater than or equal to 1, hence this equal to sign. But I hope you have got the logic behind this question. This is a very important question that you should know. Now there is one more question based on similar logic given to us. Let us try this same concept one more time. I am going to do a little bit faster this time. I hope you will be able to catch it up. So let us take the first part now. What we have is root of, this I can write as x minus 1, the first, and then I can write this as 4. Then you have a 2, this I will write as 2 into 2 root x minus 1. Now you can very fast observe this because we just did in the last question that this can but root of x minus 1 whole square. There is a minus sign, then 2 square. No, sorry. Then you have nothing but plus 2, sorry, minus 2, and then whole square. So you can see that this will become mod of root of x minus 1 minus 2. Similar thing if I do in the second part that is root of x plus 8. This can be written as x minus 1, and the second part will become 9. Then you have 6 root x minus 1. This can again be rewritten as root of x minus 1 whole square plus 3 square minus 2 into 3 root x minus 1, which eventually can be written as x minus 1 minus 3 का mod. ठीक है ना? I have shortened off one step. I hope you would be able to catch up with that. Once you have this in the next part, what the question says is nothing but you have been given mod of root of x minus 1 minus 2 and then mod of root of x minus 1 minus 3, and this is equal to 1. This is what the question says. So if you do one minor change, this everything will fall into place. If I, instead of writing this, we did this earlier also, write this as 3 minus root of x minus 1, minor change. Now you can see that this becomes mod of u, this becomes mod of v is equal to u plus v ka mod. We have got the earlier thing. So in the third part, we can write our answer by taking u into v greater than or equal to 0. So my u is root of x minus 1 minus 2. My v is root of x minus 1, 3 minus root of x minus 1. This is nothing but greater than or equal to 0. Now in order to solve this question, it would be easier if you take this root of x minus 1 st, because it is still not solved. Question ke andar there is another question that we need to solve. So if I take this as t, the first part becomes t minus 2, the second becomes 3 minus t. If I solve this, I will take the minus sign on the other side. This will become t minus 3 is smaller than or equal to 0. From Wavy curve, we will be able to solve it faster. So this is 2, this is 3. This is how the Wavy curve looks like. So this is plus, minus, plus. We will be able to accept these answers. So the values of t that are possible are nothing but the values of t lying between 2 and 3. Once you have got this, you can write the final answer in the fourth step. So my root of x minus 1 lies between 2 and 3. So if I square this up, x minus 1 will lie between 4 and 9. And as a result, x will lie between 5 and 10. So my answer becomes x belongs to 5 to 10. I hope this is a very interesting and important question. There were two small ideas even after you got the answer, and that makes this question really interesting. Now you can see that we have only one type of question that is left, that is questions based on graph. This is type 5. Now if there are multiple modular signs with linear things inside, you can again use the interpretation method, and this is definitely can be solved using this method, that method, but will become extremely lengthy. So this kind of questions where it involves linear functions inside modulus, it would be easier using graphical method. So we are going to draw the graph using table method that I taught you in the last video. So write x, y, and then draw a small table. This is going to make your life extremely easy. The first value that we can get is if I put x as 2. This becomes 0, from the second one 4 and the second one, third one 3. So x we are going to put first as 2. Another value that we can take is 3. Another value based on the question would be 4. Take something smaller than 2, it could be 0. Something smaller greater than 4, it could be 5. If I take 0 and start putting in the question, let us see what do we get. Okay, let us see what do we get. So if I put 0, you can see the first part will become 2, the second becomes 4, the next one becomes 6. There is a minus sign, plus sign, so it becomes 0. If I put the second value, let us see what do I get from there. If I put 2, the first one becomes 0, the second one will become 2, the next one will also become 2, again it subtracts and becomes 0. The next one if I do, and if I again put the value as 3, this becomes 1, this becomes 1 and this becomes 0. The value becomes 2. And the last second last, if I put the value as 4, this becomes 0, this becomes 2, the second one becomes 0, and this again becomes 2, it again becomes 0 as a whole. And finally, if I take the value as nothing but 5, this becomes 3, this becomes 1, and this becomes again minus 4, so again 0. So, if I plot up all of these values, I will be able to get my graph in step 2. So, let us draw that graph and see what are the possible values that we are getting. So, we have 0, then 1, then 2, then 3, then 4 and then 5. We have got these 5 values. So, at 0, we could see the value was again nothing but 0, wherein 2 again will have 0. 3, you can see the value jumped to 2 units. Then it was again 0, 5 was again 0. So, if I connect all of these points, this is the graph I am getting till 2, then from here and then from here and then from 4 onwards again it will become 0. So, looking at the graph, now you can answer the question. What are they asking in the third part? What is the largest and smallest value? So, first largest value if you find, this came at 3, that is 2. And smallest value if you figure out, you can see that using graph it never goes below 0, so it is 0. Now, what they are asking, sum of these values, so it comes out to be equal to 2. Using graph again, you can see that I was able to solve this question quite fast. Let us take one more example. This is given and they are asking us to simplify the function. So, again I think interpolation technique also you can apply, that will also work better in this case. So, this can also be done using interpretation. Let me do this using interpretation. Now, if this question is given, what you can do in order to interpret is put this and this equal to 0. So, what you have got is 1 here. If I put the second one 2 and if I put the last one 7, you can see that your number line is getting split into 4 parts. This will become my case 1, this between 1 and 2 case 2, this becomes my case 3 and this becomes my case 4. But before doing anything, I do not want any coefficients of x is negative. So, I will do one very simple thing and make this very much easier for me to do. This second term I am flipping as x minus 2 mod. Rest of the things I am saying, keeping it as same. Now, we will have to, in order to interpret, split it into 4 intervals. In the case 1, so first one is nothing but case 1. In this case 1, we are considering values of x smaller than 1. In this case, you can see that we did this earlier also. All the moduluses will open with a negative sign, because everything will be negative. So, first one becomes negative to 2 times x minus 1. This becomes 3 times x minus 2 and minus 5 times x minus 7. If you simplify this, this becomes minus 4x plus 30. You can do the calculation. Then we can consider case 2. Case 2 says that what happens if x lies between 1 and 2. Now, in this scenario, you can include 1 in the first part also. What will happen? The first one will open with a positive sign now. So, 2 times x minus 1 it will be. Second one still opens with a negative sign. So, this becomes plus 3 times x minus 1, x minus 2. And the third one becomes, again opens with a negative sign, minus of x minus 7. If I open these, it becomes 2x minus 2, 3x minus 6 and 5x plus 35. If you add all the values of x, 2x plus 5x minus 5x comes out to be 0 and 6 would be 29, 27. So, this comes out to be 27. Let us go to the third case now, case 3. In case 3, we are looking into values of x between 2 and 7. If you take values between 2 and 7, you can again put equal to sign at any of the places, it does not matter. So, your function first modulus will open with a positive sign second also opened with a positive sign, okay? But the third one will open with a negative sign. If you simplify, this becomes 2x minus 2 minus 3x plus 6 minus 5x plus 35. If I simplify this, minus 8x minus 2 will become minus 6x. From 35, this will get added, 4 will get, this will become 39. And in case 4 that I will consider the values of x greater than 7. In this case, the function is fine, everything will open with a plus sign. So 2 times x minus 1 minus 3 times x minus 2 and plus 5 times x minus 7 would come. This will ultimately simplify into 4x minus 31. You can check it out. So, you have got answers from all the 4 cases. What you can do, you can write it nicely. So, we can write it nicely in one function and that will have 4 parts. First part was the value became 4x plus 31. This happened when you took the values of x smaller than 1. In the second case, you can clearly see that the answer became 27. Now, this happened when you took the values of x between 1 and 2. In the third case, your answer became minus 6x plus 39. This happened when you took values greater than 2 but smaller than or equal to 7. And ultimately 4x minus 31. This happened when you took values of x greater than 7. We have interpreted this modulus into 4 piecewise defined functions. Okay? And this is very important because sometimes we'll have to solve questions by doing this. Let us do one last problem type or category before we end this discussion on modulus equations. Because sometimes there is modulus, and this question very important, modulus on both the sides. Now, this you can remove by squaring both the sides. This is a very specific scenario, modulus on both the sides. Okay. So, what you can do here is basically you can square both the sides and get your answer. So, if I square both the sides, this becomes x minus 1, the modulus will go away, x plus 5. Now, the reason the modulus is going away is because we wrote modulus as nothing but root of x square. So, if you square it up, it will become x square directly. So, if you do it like this, again you do not need to solve in the next step. You can bring it on the same side and apply the formula of a square minus b square. So, this becomes a minus b into a plus b. So, a minus b becomes 2x minus 6 and a plus b becomes 4x plus 4. So, if I equate the first one equal to 0, x comes out to be 3, equate the second one equal to 0, x becomes minus 1. So, you have got 2 answers to the question. See, if you are not sure, it is highly recommendable that you check your answers as well. So, if I take x equal to 3, put it in the question, my LHS comes out to be 9 minus 1, 8, and my RHS from the original equation comes out to be again 8. These are equal, so acceptable answer. I can put x as minus 1 and again check. So, the LHS of the question comes out to be 4 and the RHS again comes out to be 4, again equal, so acceptable answer. Now, in today's video, we have covered in detail all kinds of modulus based questions that can be asked. My advice would be to practice this question one more time, and in order to super helpful to you and help you out, I have put an assignment based on the kind of questions we discussed in today's class, so that you can practice them further, verify the answer on your own and develop better concept grip over the topic that I have taught today. In the next one, we are going to discuss modulus inequalities. So that is going to be the culmination of whatever we have learned till this point of time. It is a super important video. So if you have watched till this point of time, I will not want you to give it up. Try and do one more and then develop 100% grip over modulus equations. See you until next one. Bye.